students, welcome to Interconnecting Physics. Today in this video, I will explain you about electric dipole and electric dipole moment in detail. So without wasting time, let's get started. For further updates, you can follow me on given links. So what is electric dipole? A pair of equal and opposite charges separated by small distance. You see, pair of equal and opposite charges. Both charges are equal but sign is different and separated by small distance is called electric dipole. This arrangement is called electric dipole and the 2L is called dipole length. Now you see total charge on the dipole is 0 because minus q plus q equal to 0. Examples of electric dipole are water molecule like H2O, ammonia, hydrochloric acid, sodium chloride, carbon dioxide are some examples of electric dipoles. Now the net charge on the electric dipole is 0, but the electric field of an electric dipole is not 0. This is so important. The charge on the electric dipole is 0, net charge, but the electric field of an electric dipole is not 0. Now, next topic is electric dipole moment. The product of magnitude of either charge. Product of magnitude. Magnitude means we don't take sign, we just take magnitude and the dipole length. It is the multiplication of magnitude of either charge and dipole length. Dipole length is denoted by 2L. Now it is denoted by small p vector. Small p vector which is equal to q into 2L. We make arrow on L, not on Q, because Q is a scalar quantity. Now in magnitude form we can write P equal to Q into 2L. Now the direction of dipole moment, the most important, note this, the direction of dipole moment is from negative charge to positive charge. Is from negative charge to positive charge. It is opposite to the direction of electric field because in last topic we studied the direction of electric field is from plus q to minus q charge, but the direction of dipole moment is just opposite to the direction of electric field, that it is from minus q charge to plus q charge. Now dipole moment is a vector quantity and the SI unit of dipole moment is coulomb meter because the formula is P equal to Q into 2L. Now the SI unit of Q charge is coulomb and the SI unit of length is meter. So it is denoted by coulomb meter. Capital C, small m. And the dimensional formula of dipole moment is, we calculate from here. I have already told you, don't cram the dimension formula. Always learn the formula and calculate the dimensions and units from the formula. Now, what is the dimension formula of Q? It is AT. And what is the dimension formula for length? It is L. So, dimension formula is M0. M0 because M is 0 here. L1, T1 and A1. So, this is the dimension formula, that is M0 LTA. Now physical significance. What is the physical significance of electric dipole? What is the use of electric dipole? What is the application of electric dipole? The single answer is, the physical significance of dipole is that it tells us about a molecule is polar or non-polar. So before starting this, let us discuss what are polar molecules and non-polar molecules. So what is polar molecule? When the center of mass of negative charge, when the center of mass of negative charge means electrons and the center of mass of positive charge means protons do not coincide. There is some distance between center of positive charge and negative charge. There is distance. So such molecule is called as polar molecule. And you see positive and negative charge separated by some distance. So it means there exists some value of dipole moment. Here every polar molecule has some finite value of dipole moment. So what does tell in this physical significance of electric dipole? That we know that P equal to Q into 2L. So large is the magnitude of dipole moment. So large is the value of dipole moment, higher will be the polarity of the molecule. Suppose here the dipole moment of this molecule is, let us say, 0.2 coulomb meter. So it has some finite value. we can say it is a polar molecules, because here the center of positive charge, center of negative charge, we can't see protons, we can't see electrons, but we can see is the value. If we are given with some finite value of dipole moment, so we can detect, we can answer that such type of molecule is polar molecule. Now further, non-polar molecules, when center of mass of negative charges, means electrons, and center of mass of positive charges coincide. You see, the positive and negative charges coincide. So it means no distance exists between center of positive charge and negative charge. Distance is 0. So dipole length will be 0. So means what is the value of dipole moment? Here 0. So it means for non-polar molecules, the dipole moment has 0 value. So again, if we are given with 0 value of dipole moment, we can judge this molecule is non-polar. So come back. Here, the physical significance was, it tells us whether a molecule is polar or non-polar. Now, you can conceptualize this, that large is the magnitude of dipole moment, higher will be the polarity of the molecule. And for non-polar molecule, the dipole moment is 0. Now, in simple way, we can conclude in just 2 lines that when a molecule has finite value of dipole moment, the molecule is polar molecule, and when a molecule has 0 value of dipole moment, the molecule is called non-polar molecule. So this was about the dipole and dipole moment and the physical significance of the dipole moment. Now electric field of an electric dipole, because we already said the net charge of the electric dipole is 0, but the electric field of electric dipole is not 0. So what is the electric field of electric dipole? You see, the electric field produced by a dipole is called electric field of an electric dipole. And to calculate the electric field intensity, what we do, suppose we have minus q charge and plus q charge and they are separated by some distance. Now let us say distance is 2l. So this is a dipole. Now how we calculate the electric field of dipole? First we calculate the electric field due to minus q charge at some point. Suppose that is E minus. Then again we calculate the electric field at point P due to plus q charge. So let us say that is E plus. Now we add E minus and E plus and we calculate the total electric field produced by dipole at this point. So you see here, to calculate the electric field intensity due to dipole, we separately calculate the value of electric field due to positive charge and then due to negative charge. Then we add both values of electric field intensities and get the net electric field intensity due to electric dipole. Now this observation point where we wish to calculate the value of electric field may lie on the axis of dipole or on the perpendicular bisector of the electric dipole. So let us discuss these, what is axis and what is perpendicular bisector. So axial line, when point P, let us say point P, where test charge is present, where we wish to calculate the electric field of this dipole. So let us say point P is present here. So what does this line called as? A line joining the two charges and passing through the center. A line joining the two charges and passing through the center is called axial line. So we can say point P is present on axial line of the dipole. And what is equatorial line? A line passing through the center of the dipole but perpendicular to the axial line, perpendicular to the dipole is called equatorial line, and point P may be present on the axial line, may be present on the equatorial line. So this was all about the dipole, dipole moment, physical significance of dipole moment and axial line and equatorial line. So thank you very much. Don't forget to like, share and subscribe. Stay healthy, stay happy.